In our last video, we provided a solution to this problem off of page 326 of our elementary stats book by Mario Triola. In this video, I want to tackle number 25 off of the same page, which is about a really large sample. A Quest diagnostics analysis of 10 million drug tests revealed that 4.2% of them tested positive for illegal drugs. Construct a 95% confidence interval estimate of the positive test rate, and construct a 99% confidence interval of that rate. Comment on the results. Well, what's going on here is that we have a super large sample. Large samples are good. When our sample is large, the size of our margin of error goes down. The other thing we're told here is the actual value of p hat, 4.2% or 0.042. Well, I want to use that information to figure out how many successes I actually have. Remembering that p hat is always x over n, so if I need to go back to x here, well, I need to multiply p hat by n. So I have 10 million times 4.2%. So 10 million times 0.042. And I think we probably could have managed that arithmetic in our head. We get 420,000. 4.2% doesn't sound like a lot, and as a percentage it's not, but this reminds us that if you have a large sample, even things that seemingly have a small relative frequency still can have a surprisingly large occurrence. They can occur a whole lot. So, what I want to do now is construct the two confidence intervals we've been asked to construct, but this time I want to use my graphing calculator and show you the process that we use there. If you're watching this video as part of our course at Alamance Community College, I've typed this procedure into our Moodle course as well, so you can look at the calculator instructions there. But to create a confidence interval just using the graphing calculator, we're going to start by hitting our favorite button, the stat button. Then we're going to go over to tests. We're going to scroll down to the 11th option on the list, one prop z int. And what we see here is a spot for x in the confidence level. And so I just need to enter all that in. Now, one bit of warning. There's so many things in this sample that this had to be a whole number when I did the multiplication, but sometimes a percentage multiplied by n will give us a number of successes that seems not to be a whole number. Well, if we think about it, this is a number of successes. These are discrete random variables, so this needs to be a whole number. So if you ever get something for x that's not a whole number, remember to round to the nearest whole number. But for me, I need to type in 420,000. I need to type in the sample size of 10 million. And then we're going to do two different confidence levels, 95% and 99%. So I'm going to start here with the 95% level and go to calculate. And the graphing calculator always gives us a confidence interval in this particular format as an interval. And I'm going to round to three significant figures, badly apparently. Let's do that correctly. 0, 4, 2. All right, and what I realize is when I do that, that's not an interval anymore, so I probably should consider more significant figures than that. So what I see is two values that are very, very close together. I'm 95% certain that the actual population proportion actually falls between these two values that are very close together, and that's the effect of this very, very large sample. So now let's construct the 99% confidence interval. So we hit stat, we go back over to tests, and still go down to one prop z int. This doesn't change, the sample size doesn't change, but the 0.95 becomes a 0.99. Go down to calculate. And to be more certain, my interval has to be larger. And well, this is larger, right? My endpoints go farther away from each other. This is a lower number and this is a higher number, but they're still really close together. And again, that is the effect of a super large sample, that my margin of error has gone down and it's very small at the 95% level and the 99% level. All right, well, that's how you use your TI-83 or 84 to find a confidence interval.